contents. So today I would like to share my knowledge relating to analysis and interpretation of data using parametric and non-parametric methods. So myself, Srinivas Vemuri, Department of S&H, Vijay Institute of Pharmaceutical Sciences. So basically, in statistical aspects related study in biostatistics, statistical methods are in two parts of the study nature. One is the descriptive statistics and analytical statistics. In descriptive nature, generally we observe the basic concepts of the statistical tools which are used in all areas, not one perspective area, not in all areas. At the same time, inferential statistics, so this is purely some application based. So that in that particular inferential statistics, today we are going to observe what are the parametric tests and non-parametric tests, how those tests will be used in life sciences or in biostatistics. See, the chain of reasoning for inferential statistics. So inference is nothing but, in general sense, is nothing but drawing the conclusions. So drawing the conclusions, that it means conclusions relating to our object to study base. So in that particular aspect, the population, from the population, sample will be selected. From the selected sample, so they measure the data with different tools of statistical tools. And also, we can see the population nature relating to the population nature as far as the sample nature. So that is nothing but called the inference. So inferential statistics, method of using to make inference about the relationship between the independent and dependent variables in a population based on a sample of observations from that population. That it means here drawing the sample which leads to the independent, the sample which we are drawing from the population, that it means the dependent nature. So why it is called independent and why it is called dependent? Since with the sample based study only, we can observe the population related characteristics, because being the sample is the usually related components, is not possible, practically not possible to study the characteristics of the population. Even though it is not possible, so one should know the characteristics of the population. So for that purpose, to study the population characteristics based on the sample related characteristics. That means from the population, you have to select the sample, to observe the sample. From that, we can study the characteristics of the population. So population versus sample. So population general meaning. So population is nothing but a group of objects. Those objects may be finite or infinite, animate things or inanimate things, whatever it is. So even though that population is somewhat finite, to study about that population characteristics, that is somewhat practically impossible. Suppose, let us see, for example, we would like to study the per capita income of India. Let us suppose that. So that you have to, in that particular aspect, you have to take it into consideration the income standards of all people who are the employees, direct employment or indirect employment, whatever the source. So once you have to collect the information and standards of the income of the people, then only we can use particular nature of the population characteristic. So somewhat it is practically impossible. For that purpose, simply we can select sample-wise, area-wise, city-wise, state-wise, country-wise, somewhat. Sample will be collected and then we can observe its nature. By that, we can assess the nature of the population. So, population and sample have such a logical relation. In the sense that based on the sample only, we can estimate the population related unknown characteristics. So usually, whatever the characteristics of the population called the parameters. So population characteristics in the sense of somewhat measurable characteristics, somewhat average income standard deviations, relation between the income natures. So all those are somewhat the characteristics which can be measurable characteristics. So all measurable characteristics we consider as a constants of that particular population. So the constants of the population, nothing but called the characteristics. So similarly, sample related characteristics also we can measure. So sample is somewhat small when compared to the population. So we can use to calculate related characteristics. That it means sample standard deviation, sample correlation. So other related characteristics, whatever the possible characteristics we can study. So those are all called the sample constants. So sample constants are nothing but called the statistic. Population constants called the parameters. So that here this population parameter can be represented in Greek letters. Statistics in the sense of sample constants or sample characteristics we represent with Latin letters. So here we have to observe one thing. So basically, the sample is used to estimate the population related characteristics. That means the sample constants are used to estimate the population. So once estimating the population, that estimated population be true or false, whether you accept or reject. To know about that, you have to go for a testing. So here hypothesis testing is nothing but a statement. The testing is nothing but whether you accept that statement or not. So if the hypothesis be in a numerical related aspect, obviously that is called the statistical hypothesis. So statistical hypothesis testing, it means whatever the statement giving related to the population by estimating the sample, whether it is true or not. So to know about whether it is true or not is nothing but called the testing. So simple flat 1964 given some definition related to the testing, hypothesis testing or testing of hypothesis. If you have a hypothesis and have another hypothesis, evidently one of them must be eliminated. The scientist seems to have no choice but to be either soft-headed or disputatious. Some definition given by the Lord regarding the testing of hypothesis. So test of significance. So test of significance, statistical significance. So statistical significance or testing of statistical hypothesis, both are one and the same. Because we are testing the hypothesis relating to the population related characteristics. So once you be in that testing process, whether that test you be accepted or not, to know about that, that is nothing but the test of significance. So statistical significance means there is a good chance that relationship exists between two variables. That means accepting and rejecting, dependent and non-dependent. So here, generally, hypotheses be observed in statistical sense. There are two types. One is null hypothesis and another one is the alternative hypothesis. Because, so if you want to test, you have to make an assumption relating to your study. That it means what you make assumption related to that, that is true. That in the sense, what you are expecting, what you are estimated, the difference would be the zero. So that whatever the statement representing zero, that is nothing but it is called a null hypothesis. So null hypothesis states that there is no relationship between any two variables. One is expected variable, another one is estimated variable. So the difference between those two be the zero, then it is called a null hypothesis. So the statistical effort will be directed to prove that null hypothesis is like likely or not likely. So accepting or rejecting the null hypothesis. See, generally in any type of experiment, so one should observe some trueness maybe feel as a fault, falseness be feel as a true in general sense. So that's based on the null hypothesis that is termed. If you accept, reject null hypothesis when it is true, so there you are committing the type 1 error. So type 1 error in the sense rejecting the null hypothesis. Null hypothesis means there is no significant difference. That statement you are rejecting that. Though it is no difference, you are rejecting that. It means you are feeling somewhat difference is there. In that particular sense, that is called the type 1 error. So usually the probability of type 1 error be represented as a alpha. It is also called the level of significance. So type 2 error, obviously, the negation to the type 1 error. So whenever the statement you be prove, thinking that is true, why it is wrong? That means you are doing experiment. You feel whatever you are doing, whatever results you are getting, you feel that is true. But whatever the results you are getting, that is practically wrong. So in that particular sense, what we would observe is there. So accepting null hypothesis when it is false. So this sense of negation of the that type 1 error is called the type 2 error. So usually the type 2 error be very dangerous for any manufacturing industry, because see, type 1 error may be representing consumer risk. So type 2 error representing producer's risk. So why it is consumer risk of type 1 error? So once they producer risk, sorry, type 1 error, producer risk. Type 2 error, consumer risk. So type 1 error in this sense, once you are manufactured one product, you feel that quality standard of that particular product, you feel that is true. That is in quality. But accidentally, the quality control department, that manufactured product be rejected. So what the situation relates? Obviously, that quality product doesn't go to the market. So that we in industry only, that it means it is waste of time, material, and everything, money, everything. So that relates to the producer. So when consumer risk is there, so consumer in the sense type 2 error, probability of type 2 error, that is the beta. Beta in the sense when manufactured product, somewhat defective product, though it is defective, the quality department be, the quality department given that certified as a qualitative product and sent to the market. Obviously, the consumer will attract that, will purchase. Obviously, consumer will be in loss. That's why those accepting and rejecting a related sense by the type 1 and type 2 error. So here, this type 2 error related, whenever 1 minus beta, that is the probability lies between 0 and 1. So once that type 2 error probability 1 minus of that beta, that will give the power of the test of that particular manufactured product. So what I explained related to that, we present in a tabular form, making the decision. So usually, once you are making a statement related to the population, whether you want to test that, so you have to go for hypothesis testing procedures. Usually, in hypothesis testing procedure, there are two types. One is parametric and the other one is the non-parametric. So parametric in this sense, whatever population related characteristics be measurable characteristics, with that we can make test. That means we can make an assumption related to the population. That related tests are called nothing but the parametric tests. So non-parametric tests, we cannot find any type of assumption related to the population. So here we cannot we cannot find any assumption related to the population related characteristics. Those type of tests are called the non-parametric tests. So usually we are going through whatever tests be presented in that particular slide. We go through that. So assumptions of using parametric tests. So for any type of test, there are certain assumptions. So those are, one is the independent observations. So independent in this sense, once you are selecting the sample units from the population without any intention, you select that sample randomly, that is called independent. So once you are selecting that sample independently, identically, obviously that's sample nothing but called the normal distribution related characteristics. What are samples you are being selecting in this particular process, independently, identically distributed? Obviously, those samples having the characteristics of the normal distribution. So here normal distribution in this sense, in statistical sense, so normal population is the parent population. For any type of test, for any type of experimental base, usually we have to observe the normal related data process. Using normal data process only based on the parametric test. So normal distribution in the sense, so where it shows somewhat median mode, whatever the central tendency characteristics, whatever. So median, mode, both are equal. That means it gives the central value, either of the central value that curve distribute equally. So that it means it shows somewhat, I mean, a bell-shaped curve. So in that particular sense, when you go for testing of parametric tests, you should follow the normal distribution related characteristics and also equal variances. That one of the character and intervals and ratio scales. So these are the possible assumptions. Generally, testing of hypothesis. How we have to test the hypothesis? So what are the main basic aspects? So we can see under 5 steps model. So make assumptions and meet the test requirements. Assumptions in the sense, so whatever population related characteristic you want to be tested based on the in your experiment or research related, object related options. So whether that assumption be test meeting, requirements meeting the requirements of test requirements of the parametric test. State the null hypothesis. State in the sense, state the null hypothesis sense. So whatever you want to be studied, study in the sense, you be observe, you be want to expect something. So you have to define clearly. So that is nothing but the setting up the null hypothesis. And third one, selection the sampling distribution and establish the critical region. In this particular sense, that means here sampling distribution, nothing but whatever sample related characteristic related study of distributions are called the sampling distribution. That is maybe sample mean called the sampling distribution of mean, sampling distribution of standard deviation. So whatever character related study base you want to be analyzed. So making that particular distribution related, character related distribution. And also we have to establish the critical region. Critical region in the sense, so how far you can accept the accept or reject, percentage of acceptance or rejection relating to your study. We have to assess and we have to establish, compute the test statistic. For every sampling distribution nature, in one statistic related statistic based B, you have to set up and make a decision and interpret the results. After making that, using the test statistic, whatever the results you be obtained by based on that, you have to make a decision and interpret the results. These are the 5 major steps. So whatever the testing of hypothesis procedures, these 5 steps are the major role you have to observe. So in every type of test, in general, in academic purpose, suppose in parametric test, you may use the Z test. For Z test, you can compare with the Z table values. Suppose it is T test related table values. In certain situations, nowadays, mostly in software based, the test of that particular validity of the validity base, generally P value being used. So P stands for the probability and measure how likely it is that any observed difference between groups is to chance. It is common in medical journals to see the adjectives such as highly significant, very significant, after the quoting the p value depending on how close to the 0 values. Since p value is nothing but the probability value, probability always lies between 0 and 1. Based on the test values, we have to compare with this p value. By that, we can see how far it is true or how far it is false. So, statistically significant, you want to say a test based, that should be whatever the p value you get, the p value should be less than 0.05. So, otherwise, it is insignificant. Here, now we have to see the testing of hypothesis based on the parametric test. So in parametric tests, we can observe large samples related parametric tests, small sample related parametric tests. So in large samples, so what is meant by large sample? Large sample in the sense sample size more than 100. It is be called as a large sample. So to test the sample size is more than 30, so such a type of test is called the large sample test. So sample size is less than 30. To test such type of sample, that is called the small sample test. Test of significance for large sample test, test of significance for small sample test. Under large sample test, we can observe 2 types. One is test of significance for variables, test of significance for attributes. In general, in life science related study, generally we can observe only variable related study only. That's why. So one is single mean, variable related, and difference of means. That means that related to the 2 samples. Then in small sample, we are going to study t-test, f-test, chi-square test, and ANOVA. These are the mostly used in life sciences and biostatistics related analysis purpose. See, in large samples, test of significance for single mean, we have to use this test statistic as Z is equal to x bar minus mu by sigma by root n. X bar is the sample mean, mu is the population mean. We are finding here the difference between x bar is estimated value, mu is the assumption value. The difference between those two be significant or not, we are going to test. For that, we have to see the standard error of that. That difference be how far error in that. So based on that statistics be designed. So with that formula, we can study the significance for single mean. In certain, because the sample is more than 30, generally more or less whatever the population characteristics, as similar the characteristics of that 100 sample related characteristics. So that's why suppose if the in particular test procedure that population related standard deviation is not known, obviously we have to use the sample related standard deviation, I mean nothing but yes. So with that we have to take the test statistic related to the single mean like that. So here another two samples. So here two sample in the sense we are taking one sample from one population and another sample from other population. So we have to test whether two population difference, I mean two population are equal or not. So whether that difference be 0 or not, we want to test with that the difference. So that it means x1 bar is a statistic, x2 bar is a statistic, the difference is also a statistics. That is not the difference, that is a statistics. Similarly, respect to population differences. If it is 0, obviously that is the test of null hypothesis. So for any procedural aspect, so one should observe the framing of null hypothesis based on the given test procedure, I mean test problem. So obviously null hypothesis is like that, alternative hypothesis, once it is 0, another one is not equal to 0. So respect to standard deviation sigma 1 and sigma 2, based on that two sample related statistic, two sample difference related statistics be defined as Z is equal to like this. So see, based on that, one example I'm designed. So to use Z test, we need to assume that our population standard deviation sigma 1 and as S1, that means the population is not known, obviously we have to take its estimate as a sample standard deviation. So this is the standard deviation. So mean of the first sample, mean of the second sample. Simply we have to substitute those values here. So on observation, so you got, I mean by the calculation you got Z value calculated like this. So in general aspect, this Z value at what level we are experimenting this test. So if you would like to test that at 5% level of significance, obviously table value at 5% we have to consider. So that table value of at 5%, that is 1.96. We have to compare this value 7.5 with 1.96. So calculated value more than the table value. Obviously, we reject the null hypothesis. So reject in the sense, whatever assumption you be considered, that it means choose population means are equal. You consider that based on the sample values. That has been rejected in the sense, so whatever assumption you be considered relating to the null hypothesis, that has been rejected. That means the conclusion here is a significant difference between birth rates on weekends and weekdays. So here, that is directly, generally you can use that. So for normal tables, probability value base, as per our sense, Z value, so greater than this. So Z value less than this. This is, sorry. So 0. P value 0.0030004. So that is less than, obviously as per probability theory, probability sense, that is, significant. So like that, we can observe the. So in large sample cases, mostly in life sciences, very much experimental base, rarely we can use. But in life sciences, in the biostatistics, mostly we can use the small sample tests. Here, the small sample tests are already previously I said that, because here sample related tests based on the small sample called small sample test. So here one important point we have to observe. As per large sample, all sample related characteristics more or less related to the population. But where in sample, in the small sample cases, so that case not be exist in the small sample tests. So for that purpose, different professors, various professors designed various small sample related procedure in different ways. So for t-test, W.S. Gossett defined the t-test. He is making use of related to only means based. So based on that, one sample mean, difference of means, and parent test. So here this particular t-test and all small sample related tests are called the exact sampling distributions. So these examples, exact sampling distributions, no way concerned to the normal procedures, normal characteristics, so that it has its own individual related characteristics. So here one sample t-test criterion base. So random sample, so that should be a random, that also, so that should be a quantitative base, because variable related, mean is a variable related. So variables are normally distributed, and sample size less than 30. Normally distributed in the sense, whatever the sample you are drawing independently, identically distributed. So that sense which is representing the normal distribution. So in small sample test based on the t-test, testing of hypothesis, t-test using 7 steps. As said in a large sample test, a part of 5, another 2 will be including this. So assumption is same, state in a hypothesis, select the sample distribution. That means whatever small sample related characteristics, mean, standard deviation, correlation, whatever characteristics. Compute the test statistic. Based on that sampling distributions, we have to compute the statistics. Here we can see the degrees of freedom. So in this particular aspect, degrees of freedom is nothing but sample size minus 1. Sample size minus 1 is called the, after that, decision and interpretation of the results. Next, yes. Yes, decision and interpretation results. Next one is the confidence intervals. That means how far that null hypothesis be accepted. If it is rejected, so what would be the population mean? So whatever the test which is based on the population related study only. So we are making the assumption related to the population, something mu is equal to 100. If it is failed, I mean it is wrong. So then what would be the population mean? So that it means we are not possible to estimate that population parameter as a single value, then we have to go for estimation for interval form. Interval form in the sense at what level the population mean would be in that particular interval. About the confidence interval. So that would be defined as that characteristic plus Z alpha, that means that table value related and standard error of X bar. So based on that, if population mean we not exactly defined, then we can estimate that population using these intervals. At what level? If it is 5%, 10%, 1%, whatever it is. So here in small sample case, based on the t-test, so that test statistic we defined like this. That is nothing but called the critical ratio test. So using this, that where here the sample, because sample is very small, we can able to calculate its standard deviation using this formula. This is the basic related formula. So example, see one example. Suppose a claim is made that the average number of days a person spent on vacation is more than or equal to 5 days. That is the hypothesis, population related. So it is defined based on the sample of 16 people whose mean come out to be 9 days. So here in general, giving the statement relating to the average number of days person spending on vacation is more than or equal to 5. So whether it is true or not, we have to test. Here, null hypothesis. There is no difference between sample mean and population mean. That means here the sample mean and population mean somewhat 9. No, here given no difference, we are assuming that. We have to see whether it is true or not. Alternative, obviously, against to that. Yeah. So whatever the data given in this particular example case study, n is equal to 16. So total sample in general case 5 days. For that observation, 16 people taking 16 people and studied. 16. So there very average vacation of that sample is 9. Population given 5. Standard deviation is 3. That critical. So that critical related using that formula. So everything data is given, simply substitute and find out that t value. So it's the degrees of freedom is 16 minus 1, that's 15 degrees of. So table value related to the 5% at 50 degrees of freedom. See that whenever the level of significance is not given, usually we can assume that at 5% we want to test the accuracy. So an assumption we can take or 1% based on your test requirement, your problem related, accuracy related, we can take 5% or 1% or 10%, whatever it is. So it is mentioned based on that level of significance only, we have to compare the critical value. So here I am assumed 5%. So in T table 5% at 50 degrees of freedom, its a table value is 2.13. You got somewhat 5 point something, 5.33 you got. So calculated value is 5.33 and table value is 2.13. General comparison, calculated value more than the table value. So we reject the null hypothesis. As for P also we can see. So for that 5.33 related P value is like this. So if P value less than 0.05, then the test is significant, we can give the statement. Based on that, we can give the conclusion. There is a significant difference between sample mean and population mean. So that is the conclusion. Like that, we have to analyze and give the interpretation for. So similarly, we can observe 2 sample cases for the small sample. Just I have taken brain and liver cancer related example. Similarly, we can observe these things. In similar, all 7 steps you have to put. So another, I would take in some case study based. So one of the first, some example case study based. One of the first studies I analyzed was a tumor size study. Having an accurate measure of tumor size is extremely important because it allows a physician to accurately determine if tumor is growing, shrinking, or remain constant. He has to, that a physician to study about that. I've taken that case study in that particular aspect. The problem is that often the measurement of the tumor size is vary from physician to physician. In general, in common sense, nowadays usually no doctor will give is similar to the other doctor. So in the past, the tumor size measured using the linear distance across the tumor, but this was found to be very variable because of the irregular shape of some tumors. A new method is called the resistance criteria, traces the outside of the tumor. The method was believed to give more consistent measure of the volume of the tumor. That is the some technique of studying that particular tumor size measurements. So available data. This is so for that the scanning related Dr. 1, Dr. 2 tumor. So here, so dependent samples are like this. So whenever we have to observe the samples are equal, two different doctors, tumors related, 10 sample related observations given by the doctors. Both doctors be same or not, we are going to test. So this is related to the paired related t-test because only 10 samples are there. This is a small sample. In small sample, I mean, a difference between two samples in t-test we have to observe. So for this case, we have to calculate the difference of two doctors related measurement study. So those are the observations. So for that aspect, the difference is mu1 minus mu2. So that is delta is given. Some just we are representing like that. So the volume of Dr. 1, mu1, sample mean x1 bar, volume of Dr. 2, mean mu2. So that difference, the sample mean x bar be calculated because once you convert that paired data into a single sample base by taking the difference of those two samples, we can observe that. So in this particular aspect of study, difference between means, that is, so for this statistic, a difference of means statistic be defined as like this: T is equal to D bar minus mu. So delta is nothing but the difference of mean observations of the two doctors, that is the population. So that once that null hypothesis, there is no significant difference between the two doctors regarding the study of that tumor related aspect. If no difference means delta is 0 in that. So that is the standard deviation formula for single sample. So statistic. So null hypothesis, simply we have considered that based on observations, taking the percentage at 5%, formula substitute, we got that 0.64. So relating to the probability value 0.53, which is so peak greater than 0.05. Obviously, there is no, that is insignificant. So once it is greater than insignificant, once it is less than insignificant, that means that is significant. So the conclusion, there is no evidence of a difference in tumor volume measurement based on the physicians. So that is the one case study I have observed that based on that. Similarly, similar case study, measurement values are given. The finished value, that mean and for the two samples based on that. So that calculation is like this. Similar acids. So after t-test, this t-test can be applied for correlation also. For correlation in the sense, relation between observing the studying the relation between two or more variables. How two variables are related. Once related, how far that relation be significant, you want to test with the help of the t-test using this formula. So the next test is the chi-square test. Here, t-test is related to the variable and f also variable. F you can see in analysis variance, and the chi-square test. Chi-square test is not related to the variable because it is related to the study of the related to the attribute related characteristics. So attribute in the sense significant test between the two or more characters related studies. So chi-square test. This is a non-parametric test. Why? Because in this particular chi-square test, we cannot, we cannot observe any population related characteristics. This chi-square test purely based on observed frequency and expected frequency. So those expected and observed frequency calculated. See now. Here the chi-square test are two types. There are two types of goodness of fit test, chi-square test of independence. Independence or association. There are other tests also related procedures also there. Especially for our life sciences, mostly used for chi-square test. Is chi-square test related to the study of association and independence and goodness of it. So this is the chi-square related characteristic. So chi-square is equal to O minus E by E, OE, O minus E whole square by E. O means observed frequency, E is the expected frequency. So whatever the sample related differences are there, you have to calculate that fraction and making the sum that will give the chi-square statistic value. Like this, you can expand like this. So level of significance usually 5%, 1%, or 10% in general. For any type of life sciences, usually 1% is the best because life sciences related study or biological sciences, science related, mostly we will prefer only 5%. So uses of chi-square, goodness of it, test of independency, contingency, homogeneity, all are equal, and detection of linkage in genetics. So in life sciences, mostly chi-square test very often used. So this is the procedure. For alternative calculation of chi-square using the test statistic, degrees of freedom, tabulated chi-square value, and corresponding calculate the chi-square value with compare with the table value. So this is the procedure we have to follow. So that is the comparison with the value. We accept the H0. Otherwise, we reject the H0. So in chi-square test, we follow the procedure. Chi-square thickness of it by 2 or R by C contingency more than 2 by 2. Here I have taken one example relating to the vaccination group. So out of 2 groups, each with 15 animals, one group was vaccinated against a particular disease, and 13 animals vaccinated group, and 7 animals are vaccinated. Could serve after the vacation, test whether the vaccination is effective or not. So in this particular case, vaccination is not effective. You have to consider the null hypothesis, because once it is effective, no need to go for test. Once, if you consider, I mean, taking the assumption it's not vaccination is independent, that means nowhere related, no association between two vaccination, or no effect of the disease or vaccination is effective. So alternative against to that. So whatever the data given, we presented in a tabular form. In this tabular form, we have to calculate. In general, any statistic, I mean, chi-square related contingency table to calculate using the chi-square statistic. One assumption is there: no observed value P less than 5. If it is less than 5, that formula will not be valid. So though it is not valid, you have to go for X correction without using the other formula. Another formula you have to use. So that is the X correction used. That formula not presented. Sorry. So whatever that calculated without calculating expected frequencies, these are the expected frequencies we calculated already expected. So we have to calculate the 13 corresponding expected value, that corresponding row total into corresponding column total divided by the total frequency. So that is, so like that, for 2 by 2 means 4 values, observed values are there. For each value, we have to calculate that corresponding expected frequencies. So with that expected frequencies, using the chi-square formula, so we expand that total, that some value will get 5.4. This is without using, that is called the X correction, I think. X correction. So based on that value, we have to compare with the table value. Usually row minus 1 into column minus 1. In general, in tabular form, rows to columns are there. The degrees of freedom for that tabular form R minus 1 into C minus 1, 2 minus 1 into 2 minus 1 degrees of freedom. So it's a table value. With the table value, you have to compare. So similarly, so you have to observe for 3 cases, more than 2 also. I did this example for each case, especially for this case, you have to calculate only for expected frequencies. Calculate it like this. Here we place observed and expected frequencies. Based on that, we calculated chi-square values. So we got the chi-square value 30.698. So here, how many number of rows and columns you have to check up? So here 3 by 3. 3 by 3 means 3 minus 1 into 3 minus 1. That is 2 into 2, 4 degrees of freedom. At 4 degrees of freedom, at 5% level, we have to observe the table value, compare B. So with that, whatever the assumption you have been considered, if it is rejected, obviously there is a significant difference, we can say. So next, in parametric test, next phase is the analysis of variance. This is the most important aspect in life sciences study. So analysis of variance, one way and two way. So analysis of variance is nothing but the observation of total variation of the entire group data. So that by that we have to observe the significance of variance of that characteristics we have to observe. So once we want to test different group of, a large group of people with different characteristics. So we have to make all that group into a single characteristic base. We have, if you divide like that and make analyze. So in that particular aspect, we have to use the analysis of variance. Is the extension of two sample t-test, extension of two sample t-test. In this particular category of study, in the analysis of variance, one-way analysis of variance and two-way analysis. Because if you divide entire data single characteristic base and make analyze that particular characteristic nature, that is called the to analyze that is called the one-way classification analysis. If you divide the entire data into two category base, two characteristic base, and make analyze, the total variation is significant or not. For that purpose, we have to use the two-way classification. The analysis is also there, three-way, based on three characteristic based study. We have to use the three-way classification analysis. More than that, multivariate we have to use. See, two variable, categorical and quantitative. Do you mean that quantitative variable depends on which group? Given by categorical variable in the individual is in. If categorical variable has only two values, ANOVA one way. So one way analysis of variance is used to test the claim that three or more population means are equal. In small sample base, two population related values we can test. Mu1 is equal to in ANOVA. More than that, we have to apply ANOVA. So single characteristic base we are observing to use the one way. This is the extension of two independent sample t-test. One way, conditions and assumptions. The data are randomly sampled. The variance of each sample are assumed to be equal. The residuals are normally distributed. Residual in the sense errors. Error be randomly distributed over the samples. So some example is taken. Score for the students on the second examination was recorded like this: front, middle, back students. So based on that, we have to calculate between the treatments. Between the treatments in the sense, front between grouping, front sitting people, middle sitting people, back sitting people. So each are the three groups. Each be divided into three groups and observe. To observe the difference between those three groups called as a treatments. So for that, treatment samoscale you have to choose within the group you have to study. Each group variation how much is the total. So like that we have to analyze ANOVA in this aspect. So some standard deviation. So for this data, so calculated values based on the formula related, you'll get these values. You have to tabulate like this.
Okay.
Yeah. So another example, I will take it. So the following data represent the operating time in hours of the 3 types of scientific pocket calculators before a recharge is required. Determine the difference in the operating time of the 3 calculators. Do the analysis of variance at 5% level of significance. So like these different brands related values. So based on the calculations, because manually it is calculated somewhat difficult and will take much more aspect with the software related analysis. So tomorrow you will see that procedural aspect using the softwares. So whatever the results you will get, be placed like this. Similarly, two-way analysis of variance. So two characteristic based study. These are the assumptions. Populations from the which is samples are obtained must be normally and approximately normally distributed. Samples must be independent. Variance of populations from which the samples were selected must be equal, and the groups must be equal in same size. So those are the certain assumptions. The comparing the group means like this. Certain procedural aspect is you have to follow in this. So so here teaching methodology 1, methodology 2. So here each methodology base you have to add. By that you will get 3 rows and 3 column base. You have to make all. You have to add all 3 here. Like that, each group wise you have to calculate each group. There you are getting that individual base. So making those teacher factors A, B, C, each factor be with 4 are there, 5 are there, you have to add. So by that, you have to calculate like this. Related table, related calculations. After getting the calculations, you have to be placed like this. So here in two-way, that means one character may be significant, other character may be insignificant. That shows the variation, that shows the total variation. Total variation that includes both characteristic type of analysis, both are insignificant, both are significant. One insignificant, other may be significant. So individually you have to study each characteristic base. Another, so far we observed all parametric tests, and now we have to observe the non-parametric tests. Usually in life sciences, these non-parametric tests will be used. One is the sign test, another one is the Wilcoxon's rank sum test, Wilcoxon signed rank test, Kruskal-Wallis test, Spearman's rank correlation coefficient test. See here, what is non-parametric test? So non-parametric test is nothing but no way related to the parametric study. It has no assumption related to the population parameter. Simply, it is related to the specific group-based study. It doesn't. It will not be consider any type of parametric measurement aspects. So that's why it is called the distribution free test. Non-parametric test is also called distribution free test because no assumption related to the population parameter. So no normal related test procedures we can observe. So only that related to other aspects of calculations given by the certain type of sign test, Wilcoxon related test procedures we can follow. So non-parametric procedures. The statistics not depend on any population distribution. Distributed maybe normally or ordinarily scaled. So may involve population parameter such as a median. Here only consider median. Median in the sense the central value of that particular entire data. Entire data be observed through median only. No other characteristic can be observed. So these are the certain advantages we observed. So usually with all scales, irrespective of scaling aspect, easier to complete, develop before wide computer later, mostly computer-wise later development, make fewer assumptions, need not involve any population parameter. Results may be as exact as parametric procedure. So, though it is not related to the parametric methods, so the results may expect whatever results we observe in parametric as similar to that we can observe. These are the certain disadvantages. May waste information, use information you have to collect. And example, convert data into ratio scale or ordinal scale. Difficult to compute by hand for large samples. So that's why the software will be used. The table is not widely available because for each test, whatever test be designed for this study, for each test, specific test-based tables will be obtained. No general aspect. So availability is here a comparison with so one sample, Wilcoxon signed rank test, Z test or T test. In one sample, in parametric test, one sample test related to the Z test or T test. Here, non-parametric Wilcoxon signed rank test be used. Two independent samples, Wilcoxon's sum rank test in non-parametric. Here, two sample T test. Paired Wilcoxon signed rank test. And one sample, quantitative sample, qualitative, not quantitative, qualitative correlation coefficient, correlation. So qualitative or quantitative, either of the cases we can use. So those are the comparison between parametric and non-parametric. See, in this particular slide explains us, so parametric test corresponding non-parametric purpose of the test. What purpose it will serve? T test for independent sample, just previous comparison, Mann-Whitney U test compare two independent samples. T-test independent samples, two samples, paired T-test. Here, Wilcoxon paired signed rank test, examiner set differences. So for correlation coefficient, rank correlation coefficient, assess the linear association between two variables. One way analysis, F test, Kruskal-Wallis test. So compare three or more groups. Once in parametric case, more than three, we have to apply the one-way classification. Whereas in non-parametric, we have to use the Kruskal-Wallis. So for research purpose, your data be relating to either this case or this case, that relevant test procedures we have to apply. Here, Wilcoxon rank sum test example. So here, so we are a production planner. You want to see if the operating rates of two factories is the same or not. See here in parametric test, the average are equal, standard deviations are equal. That means parametric related comparison you can see, but here distribution related comparisons. Here distribution is nothing but here we consider that two factories are same or not, we are observing. In this particular method of study, we have to use the non-parametric. So this is the data given for this. We have to observe two distributions are equal, shift or right. Against the alternative hypothesis, you have to write, null hypothesis, you have to write the alternative hypothesis. You have to test it 10%. N1, here their sample is 4, N2 is 5. So that critical value can obtain. So here this is a comparison. So data is this. In this particular aspect, what you have to do is the pooling of factory 1, factory 2 related values, give the ranks in order of magnitude. See, like this. So order of magnitude in the sense in ascending order. The lowest value here is 71 given first time. Like that, you have to allot the ranks and add the ranks, first factory related ranks and second factory related ranks, add like this. After this, so see, total ranks be added. So the ranks related to the related to distribution 1 and distribution 2 make it total. Sorry. So this is factory 1. Sorry, factory 1 ranks total, factory 2 ranks total. So take the minimum, whichever is the minimum, you have to consider based on that decision. So relevant Wilcoxon sign rank test. Sorry, Wilcoxon rank sum test. Whatever it is related to the table be available in statistical tables. In that, we have to observe. We have to observe corresponding sample size 4 and 5. Pick up that particular table value. Compare with this. Based on that, we have to write the conclusion. So here the table value. If it is 13, reject. Less than 13, reject. Do not reject H0. Means between 13 to 27. If the value is like that, so do not reject H0. and reject H naught. If it is more than 27, so the smallest value is 25.5 here, which includes in do not reject H naught. So that is no evidence of distribution. So like that, we have to observe. So similarly, if it is more than, the large sample case, we have to use this procedure N1 first sample, N2 second sample size. Using the sample size, we have to use the statistic. Next is the Kruskal-Wallis test. So already we observed the comparison. As far as non-parametric cases related for 3 population related characteristics to be compared. For that purpose, you have to use the Kruskal-Wallis test or H test. So this is the formula. So I will show that. So some test procedure, example, match 1, match 2, match 3. We have to pull up all and take assigning the ranks to that. Assigning, pulling ranks to that. Based on that ranks, each so here match 1, match 2, match 3 related overall based ranks you should assign, and some each column by getting ranks you have to add, that is R1, R2, R3. So this is the expansion that rank sum like this. For this test procedure, you have to calculate the chi-square test using the chi-square based comparison, H value with chi-square. So another one is a Mann-Whitney U test. So Mann-Whitney U test, in parametric test, difference of 2 sample base. There parametric case, you have to use the 2 sample case. Here we have to use the Mann-Whitney U test in non-parametric case. A certain procedural aspect. So you have to give ranks here also for data wise, X data corresponding ranks, Y data corresponding ranks. You have to add the ranks. So we have to calculate U1 and U2 based on this formula. Minimum of U1, U2, whatever totals you got. So that value is 3. So I compare with this is the table value based on Mann-Whitney U test table. Represent with the samples, the table value be the 2 value. So you are getting 3. So we have to accept the, because calculated value less than here the calculated value 3 and table value is 2. So here in this particular we have to write the conclusion, calculated value more than the table value, we accept H0 in this particular concept base. So here we accept H0, conclude that 2 drugs are equally effective. So whatever the conclusion we carried out. Equal effect, not equal effect. So So that ends the topic. So please ask any queries relating to the subject, because parametric and non-parametric methods, somewhat application advanced methods need much more calculation. That's why I placed directly values. I explained that tomorrow you can expect that with the software based evaluations relating to these concepts. So based on this theoretical aspect, anybody having doubts, please ask. Anything?
Some of the participants asked, sir, please share your PPT in WhatsApp group. That will be very
sure.
useful for us.
Sure. Any doubts in this analytical process? Not calculations, because calculations are so lengthy. That's why I placed directly the somewhat results what I calculated. Okay, that procedural aspects in that particular procedural aspect. Anybody having doubt, please ask. I'll try to clarify your queries.
Otherwise, we can send it in the chat box also. I think no queries from the audience, sir. Participants. Okay, sir, we can go for vote of thanks. A very good evening. Please, sir.
Thank you.
Okay, sir. A very good evening, all the participants, and today's resource person, Dr. Srinivas, sir. On behalf of Principal and IQAC vipwprincipal, I would like to thank you very much, sir, for active participation in this faculty development program. And we are delighted to have you, eminent statistician as my colleague and today's resource person. And thank you, sir, for wonderful talk on analysis and interpretation of data using parametric and non-parametric methods. Really, it is very useful and informative, sir. You have started from beginners point of view and explained it with example of data and various tests like Z test, T test, ANOVA test, chi-square test, Wilcoxon and Crucial-Walker test. After this completion of this session, we have gained the confidence on difference between the parametric and non-parametric methods to test the research results for data interpretation. Thank you, sir, for giving knowledge on different types of tests. I thanks to all the participants for your active participation and patient learning. I thanks to all the my dear colleagues for your support and guidance. I would like to thanks management and principal Vijay Institute of Pharmaceutical Sciences for Women for given opportunity to conduct this faculty development program. Thank you all for giving me opportunity. Thank you very much.
So thank you.
Thank you, sir.